Hello everyone. Today we are starting with chapter 2nd, that is the origin and evolution of the earth. First topic that we are going to cover is origin of the earth. The origin of the earth has been tried to be explained by multiple theories, and these theories were divided into two sets. It is that classified into two sets, early theories and modern theories. One of the earlier theories proposed and widely accepted was by German philosopher Immanuel Kant, which was revised by mathematician Laplace and was called Nebular Hypothesis. Let's look into what was Nebular Hypothesis. So Nebular Hypothesis proposed, okay, first Nebular Hypothesis, or it was also known as gaseous hypothesis or condensation hypothesis. What this proposed was there was a very big cloud of hydrogen, helium and dust particles, and it was rotating in an anti-clockwise direction very slowly. When gravity started acting on it, it started to pull matter inwards, which led to the core to get denser. And as matter was colliding with each other or due to friction, the temperature started rising. As the cloud got smaller, in order to conserve the angular momentum, the speed of rotation increased. The conservation of angular momentum here was explained by Laplace. In order to explain the increase in rotation speed, conservation of angular momentum had a role to play. This was explained by Laplace. If we want to understand the conservation of angular momentum with an example, we can say that how an ice skater, when they start rotating and they are comparatively, when they are bigger, as such their hands are spread, they rotate at a certain speed, but when they scrunch down, get their hands closer to the body and scrunch down, in a way get smaller, they start rotating comparatively faster. In the similar manner, this cloud started rotating faster, and as it started rotating faster, centripetal force started acting on the particles and started pushing the particles away from the center, while gravitational started trying to pull them inwards towards the center. Hydrogen and helium were at the center, concentrated at the center, as they can withstand higher temperature, which eventually formed our protosun. And as centripetal force and gravitational force were working against each other, this cloud formed into a disk shape, converted into the disk shape. As the particles were undergoing accretion, it is that they were colliding, undergoing cohesion, and were staying stuck with each other. They started forming planets, and our protosun eventually formed the sun. This is the nebular hypothesis as was proposed by Immanuel Kant. Now, if we go to the next theory, which was proposed by Chamberlain and Moulton in 1900s, that was also known as the wandering star theory. This theory suggested that a star was passing by the sun very closely, and when it did, the filaments of matter started forming due to tidal force. This led to formation of a cigar-shaped structure, and as the temperature went down, these filaments solidified and underwent collision, therefore formed planetsimals, which eventually formed protoplanet and lastly planet. This theory was supported by Sir John and Sir Jeffreys. Then came the concept of binary theories, which was proposed by Sir Russell and Sir Lyttelton in 1930s. This theory suggested that the sun had a companion, and when there was an instability, it is there maybe a flyby star or some sort of instability that happened, the companion started shedding material, which eventually started condensing due to the decrease in temperature and eventually formed planets. Lastly, we come across a theory which is called capture theory proposed by Sir Otto Schmidt and Carl, sorry, this is Carl Wazasker. I'm sorry if my pronunciation is wrong, but the capture theory suggested it is almost the revision of nebular hypotheses. There are not a whole lot of differences. It is kind of a revision of nebular hypotheses only. So what is suggested was there was a pre-existing sun which was surrounded by nebula, which had dust particles, which underwent friction and collision. Then, as it was rotating, it formed into a disc-shaped cloud. When the dust particles underwent accretion, they formed planets. Okay. So here, these are our early theories. Now, let's look into the modern theories. One of the most widely accepted by the scientific communities is the Big Bang theory, also known as the expanding universe hypothesis. Uh, we'll look into the Big Bang theory, but there was one more theory there is one more modern theory, which is a steady state theory given by Sir Fred Hoyle. We'll look into this theory first. Okay. So, the steady state theory given by Sir Fred Hoyle, it was given in 1948, suggested that universe has no beginning, no end, it has always existed and is expanding. But as the new matter is continuously being created, so are the new as the new matter is being created, so are the galaxies, and therefore the average density of the universe remains constant over the time. Hence, okay. Now we'll look into the Big Bang theory. Okay, the Big Bang theory, it was when it was proposed, it was not necessarily called the Big Bang theory that came later on, but the early idea was given by Lemaitre. Again, please pardon my pronunciation if they are wrong. What he suggested was there was an early atom which underwent explosion. So, what the Big Bang theory or the expanding universe hypothesis thesis explains is that there was singularity, which is kind of a teeny ball which had infinite temperature, infinite density, and had unimaginably high volume. This underwent an explosion, which is called the Big Bang, about 13.7 billion years ago. And within the fractions of seconds of the expansion of the explosion, rapid expansion started, and as it grew, energy started getting converted into matter. And within 3 minutes of this explosion, first atom uh, came into being. Within 3 lakh years of the Big Bang, temperature dropped to 4500 Kelvin and gave rise to atomic matter, and universe became transparent. So this is the Big Bang theory. In 1920s, Sir Edwin Hubble proved the expanding universe. It is that the universe is continuously expanding. This was proved by Sir Edwin Hubble in 1920. Okay, so now we took as I had earlier explained, how Sir Fred Hoyle gave the steady state theory. Actually, in 1948, when he was giving the steady state theory, in 1949, uh, he mockingly came up with the term Big Bang. It is that when he was giving the concept of the steady state, he in a radio show or something mocked this particular theory, that is the Big Bang theory, and mockingly came up with the term Big Bang, but somehow it stuck around and today it is known as the Big Bang Theory. And finally, in 1965, Big Bang became widely accepted after the discovery of cosmic microwave background. Sorry. Okay. Now let's get into the next topic, that is the star formation. Okay. Around the star formation is said to have occurred 5 to 6 billion years ago, and as stars are the building blocks of the galaxies. Please remember this, stars are the building blocks of all the galaxies. In the earlier, the energy and matter were unevenly distributed in the universe, and as there were variations in the densities, therefore there was also variation in the gravities. This led the matter to draw together, and this formed the basis of our galaxy formation. Galaxies can be of the diameter of 80,000 to 150,000 light years. Now, as the galaxy formation starts, it is that there's a cloud that contains hydrogen and helium. It is that there's a nebula. This grows or starts rotating. There are localized clumps of gases. When these clumps of gases get denser and they grow into denser gaseous bodies, they form our stars. We can look at the text. The next topic that we are coming across is the formation of planets. Let's look into it. About 4.6 billion years ago, the formation of planets had happened. Now, as the stars have formed from the leftover matter, the planets are said to be formed. How is that? Let's look into it. The star has already formed. Here is the leftover matter. This again undergoes the gravitational force. The gravitational force starts acting, I mean, and the as the cloud shrinks into disk of dust and gaseous clumps, cohesion starts happening, gaseous clump starts condensing, and as they start condensing, planetesimals form. After, as the planetesimals forms, as planetesimals are nothing but a larger bodies containing many smaller clumps, condensed clumps, they undergo more collision, gravitational force, and accretion, which eventually lead to formation of planets. Finally, our solar system. Okay, so the solar system. Let's look into it. There are 8 planets in our solar systems, more than 200 moons, like example, Earth's moon, Jupiter's largest moon, that is Ganymede, if I'm not wrong. Please look into it, the pronunciation if it is incorrect. Here is the a visual diagram of our solar system. There is Sun, then there are 8 planets, and there's a belt separating first 4 planets from the last 4 planets, and the planets between the Sun and the belt of asteroids, also known as Kuiper belt, are called terrestrial planets. Terrestrial means more Earth-like, and after the Kuiper belt, there are 4 planets which are called Jovian planets, means Jupiter-like. They are giant gaseous planets. Okay. Terrestrial planets have heavy elements like rocks, metals. They have high density, and are as they are closer to the parent star, therefore they as they were closer to the sun, they had higher temperature, and therefore they were too warm for gases to condense. And as the solar winds were higher or more intense in these among across these 4 planets, the gases blew off, and as they were smaller as well, their gravitational force was lower, and therefore they could not hold gases. When it comes to Jovian planets, they were distant, therefore cold. Solar winds were not very intense, and as they were larger, were able to hold the gases. Okay, this is the differentiation that is given in the text as well. Please go through it. Next is the moon. As everyone knows, moon is our only natural satellite, as in the Earth's only natural satellite. And in 1838, Sir George Darwin suggested that Earth and moon were formed from a single rapidly rotating body, and eventually, which we can see here. Okay, just I'm sorry. Okay. Let's look here. The formation of the moon is suggested to have happened somewhat 4.4 billion years ago. And early theory, as I said, was given by Sir George Darwin in 1838, suggested that moon and Earth and moon have formed from a single rapidly rotating body, that is a mass that was rotating. Eventually, it started rotating faster. It formed a dumbbell-shaped body, and eventually, a part of it, a mass of it broke, and it started rotating the Earth. It is that the main mass, and hence formed the moon. There is one more explanation, that is, moon's material came from now Pacific Ocean depression. That is the depression over which the Pacific Ocean is right now. That's where the moon's material has come from. But then there comes the theory, that is the big splat theory or the giant impact theory, which suggests that Earth had once collided with uh, a body as large as the size of 2 to 3 times of the Mars, and when it collided, the a very a very substantial part of the Earth got blasted, and this blasted part of Earth was released into space, which eventually started orbiting the Earth. This is what is our moon. This is our moon. That is explained by the big splat theory. Okay. Finally, we come to the evolution of the Earth. Let's have a look into it. Okay, evolution of the Earth. Early Earth was rocky, barren, and hot, and had mainly hydrogen and helium as the atmosphere was very thin. Our Earth structure is layered and non-uniform. So let's first look into the development of lithosphere. In the earlier stage, that is the primordial or early stage, most of the Earth was in a very volatile state. And as gradually the density started increasing, that led to a rise in temperature as well. As this happened, materials started separating with respect to their densities. It is when these materials started differentiating with respect to their densities, the heavy materials started sinking towards the core, and while the lighter material remained on the surface. As time passed, material cooled, condensed, solidified, and the as they solidified and gotten in, and they turned to smaller, when they turned into smaller sizes, there formed crust. Then, as the big splat happened, that is the formation or of the theory where the moon formation is explained. When the big splat happened, Earth heated up again because of the friction collision. It started heating up again, and via the process of differentiation, the material separated with respect to with respect to their densities into different layers. It is that. Therefore, today we can therefore we have non-uniform layers. It is that we have crust, mantle, outer, and inner core. Finally, we have evolution of atmosphere and hydrosphere. The evolution of atmosphere and hydrosphere altogether, as hydrosphere itself is formed in second or third step of the entire. Finally, we have evolution of atmosphere and hydrosphere. This evolution is given in three stages. The first stage is primordial stage, where the primordial atmosphere, which had high hydrogen and helium, was stripped off by solar winds. As the magnetic field was very weak, the solar winds were strong, as it is intense as well on terrestrial planet. It blew away the gases that the primordial atmosphere held. In the second stage, the volcanic eruption started, and as the volcanic eruption started, gases and water vapor started getting released from the interior of the earth, and this entire process was called degassing, also sometimes called volcanic outgassing. Therefore, the gases like CO2, methane, ammonia, nitrogen, etc., started getting released. But remember, yet we had no free oxygen. In the final stage, as the temperature started getting lower, it is that when the temperature decreased, water vapor started condensing, which led to rain, and this cycle continued repeatedly. Therefore, the craters that were on the surface of the earth started being filled with water, and oceans formed. This happened about 4 billion years ago. And somewhere around 2.5 to 3 billion years ago, photosynthesis started evolving. It is that we can say blue algae or cyanobacteria started doing photosynthesis in the ocean, of course. And as the photosynthesis evolved in the ocean itself, the oxygen was started to the oxygen started getting released. Eventually, when ocean got saturated with oxygen, it started releasing the oxygen in the atmosphere. So about 2 billion years ago, oxygen from ocean was released into atmosphere. This is the explanation for uh, evolution of atmosphere and hydrosphere. Finally, we come to the topic origin of life. Okay, this is said to be the last phase of Earth's evolution. In this, it is explained that how the origin of life happened is a chemical reaction. This chemical reaction formed complex organic molecules which assembled in a way that this assemblage was such that they could duplicate themselves, therefore converting inanimate matter into living substances. The record of life is studied by fossils. It helps to study fossils help to study the record of life. And blue algae, it is that cyanobacteria, has been found in the structures, geological structures, and they are dated earliest back to 3 billion years. Therefore, there is an assumption that life may have begun evolving somewhere around 3.8 billion years ago. That's it. That is the end of chapter 2 of Physical Geography NCERT. And go through the chapter once. I have explained the major concepts possible, and please go through the chapter